Module 6, Lesson 1, Posing Statistical Questions. So I have gone through and modified this presentation so that it's a little bit shorter. So some of the exercises and examples in the full lesson will not be included, but hopefully I have covered the essentials. So taking a look at the I can statements, I can show and explain the difference between statistical questions and questions that are not statistical. I can formulate a statistical question and explain what data could be collected to answer the question. I can show and explain the difference between categorical data and numerical data. Before we jump into the lesson any farther, please remember to pause the video whenever you need to. Take notes, jot things down, be smart learners. Alright, so what are statistics? One of those words that we hear a lot. Statistics is about using data to answer questions. And in this module, we've got 4 steps that we're going to use as we work with data. Step number 1, we're going to pose a question that can be answered by data. Step number 2, we're going to determine a plan to collect the data. Step number 3, we are going to summarize the data with graphs and numerical summaries. Step number 4, we're going to answer the question that we posed up in step number 1 using the data and summaries that we collected. We're going to guide you through this process as we study these lessons. Today's lesson is about this first step, posing a question that can be answered by data. In other words, we're going to identify what is a statistical question and what does it mean that a question can be answered by data. So taking a look at an example here. Jerome, a 6th grader at Roosevelt Middle School, is a huge baseball fan. He loves to collect baseball cards. He has cards of current players and of players from past baseball seasons. With his teacher's permission, Jerome brought his baseball card collection to school. Each card has a picture of a current or past Major League Baseball player, along with information about the player. When he placed his cards out for the other students to see, they asked Jerome all sorts of questions about his cards. Here are some of the questions they asked. What is Jerome's favorite card? What is the typical cost of a card in Jerome's collection? For example, what is the average cost of a card? Or maybe what is the most expensive card? Or what is the least expensive card? Are more of Jerome's cards for current players or for past players? Which card is the newest card in Jerome's collection? What is the oldest card in Jerome's collection? So we have here a situation and we have lots of questions that are being asked. We need to identify which of these questions would be a statistical question and why would it be a statistical question. In other words, what is a statistical question? A statistical question is one that can be answered with data and for which it is anticipated or expected that the data, the information collected to answer the question will vary. So there are 2 things that make a question a statistical question. The first, we can answer the question by collecting data. That gets us halfway there. And when we say data, we mean information. We collect information to answer the question. That's half of it. The second half is that we expect that our information, our data, will have some variability in it. It will vary. There will be variety. If there is only one answer to the question, it does not vary. So we're looking for questions where we expect that we're going to get some different answers. That's what we mean by anticipated. We expect that the data is going to have different answers, a variety of answers. This would probably be a great place to pause jot down a couple of notes and think deeply about this, because the entire unit is built around the concept of a statistical question. So we're going to look at a couple of examples, and we're going to decide if this question is statistical or not, and we're going to explain our thinking. So here's a question: how old am I? Now, if I'm trying to determine if this is a statistical question, the first thing I have to ask myself is, will I collect information to answer this question? Well, yes, I will collect information to answer this question. Great. Halfway to a statistical question. The second half is, do I expect there to be variability? Do I expect a variety of answers, or is there only one answer? And the answer to this is, there's only one answer to how old am I. So even though we are going to collect information to answer the question, we do not have variability. This is not a statistical question. And down at the bottom, it explains that. The question, how old am I, is not a statistical question because it is not answered by collecting data that vary. We do not have variability. Now, I could rewrite this question. I could ask the question, how old are the students in my school? I will be collecting information, and I expect there is going to be a lot of variability in the answer. So remember, statistical questions have two parts. We are collecting data to answer the question, and we expect that the data will have variability. All right. How tall is your 6th grade math teacher? Statistical question or not? Well, let's check it. Am I going to collect information to answer this question? Yes, I am going to be collecting information. Probably going to be getting out some type of measuring tool and actually counting a number of units to represent the height of the 6th grade math teacher. So definitely going to collect some information. Is there going to be some variability? And the answer to that is no. The height of your 6th grade math teacher is not going to vary. Your 6th grade math teacher has one height. The person teaching this math lesson doesn't have different heights. So no, this is not a statistical question. We do collect data, but we do not have variability. So here's another one. What is your hand span? So you measure from the tip of the thumb to the tip of the small finger. Is this a statistical question, yes or no? Well, I am going to be measuring, so I will be collecting some data. However, my hand span does not change. So this is not a statistical question. I would just measure my hand span. It would not be answered by collecting data that varies. I am collecting data, but the data does not vary. Now, something else that we will spend more time later on looking at is how much variability is there? How much variety do we have in our answers? But let's just take a brief moment and kind of prime the pump here, kind of get our brains thinking about this, so this is in the back of our head for later. So we have two questions here, and they are going to generate information, they are going to generate data, but we are trying to determine which one we would expect the greatest variability, the greatest change, the greatest variety in our answers. Would we expect the greatest variability to be in the number of minutes students in our class spending getting ready for school, or we expect greater variability in the number of pockets on the clothes of students in our class? And this would be a great time to pause and to think about this for a minute. Which one of these would probably have the greatest variability? The number of minutes getting ready for school is probably going to vary the most. If we've got 25 students in our class, we probably have 25 different answers. But if we ask about the number of pockets that each student has, we're probably going to have a much smaller variety of answers. So we would have greater variability in the number of minutes getting ready for school than we probably would with the number of pockets each student has. All right, a quick look at just a couple of exercises. For each of the following, determine whether or not the question is a statistical question and give a reason for your answer. So I would pause the video before each of these questions and I would try to answer it and then compare your thinking with my thinking. Who is my favorite movie star? Statistical question or not statistical question? This is not a statistical question. We are going to collect data. We're going to collect the name of a movie star. That is a piece of information. However, there is not going to be variability in the data. If you answer the question for favorite, there's only one answer. Compare that to this question. Who are the favorite movie stars of the 6th graders? Once again, we're going to collect information. We are going to collect names. But we're going to be asking a whole bunch of different people. So not only are we collecting information, but we will have that variety, that variability in our responses. So this would be a statistical question. Remember, pause before each question, stop and think about it, compare your answer with my thinking. All right, statistical or not statistical, what are the favorite colors of 6th graders in my school? Well, I'm collecting data. The data that I'm collecting is favorite color. Do I have variability? Well, let's see. I'm getting my data from the 6th graders in my school. If there are 75 6th graders in my school, it's possible that I could have 75 different answers. So not only am I collecting information, but I am expecting that there will be some variability. This is a statistical question. This is a statistical question because to answer this question, you collect data by asking students about their favorite color, and there would be variability in the data. The favorite color would not be the same for every student. What is the favorite subject of 6th graders at my school? Pause, think about this for a second. Well, let's see. I am collecting data. What is the favorite subject? I am collecting from the 6th graders at my school, which means I could have maybe 75, 80, 120 different responses. So I would definitely say I am collecting data. And I expect there to be variability. This would be a statistical question. This question is not a statistical question, and you need to explain why is it not a statistical question. Explain why this question is not a statistical question. Well, let's see. I am collecting data because I'm collecting the age here. I'm collecting data from one person. Do I expect there to be variability if there is only one person? So I have information. That's a definite plus there, but I do not have variability. This is not a statistical question because we do not anticipate there being variability in our data. Is this a statistical question? Well, let's see. What's my favorite color? Now, there are two things that a statistical question needs to have. I need to be collecting information, I need to be collecting data, and I need to expect there to be some variability, some change, some variety in the data that is collected. Well, I'm collecting information about favorite color, so that's a definite plus. But my favorite color, I'm only asking one person. which means I cannot have variability. This is not a statistical question. Even though we are collecting information, we do not have variability. Ronnie, a sixth grader, wanted to find out if he lived the farthest from the school. Write a statistical question that would help Ronnie find the answer. So we've looked at whether or not a whole bunch of other examples were statistical questions. Now what we need to do is we need to actually say, how would I write a statistical question? And this would be a great time to pause the video, stop, and think, and come up with your question, and then compare that to what we come up with. Well, first thing I need to know is what information do I want to find out. So I'm going to be asking classmates how far they live from school. Now, how do I pose my question so that it has the variability? I'm collecting the data, distance from school, but I need to have the variability in play. So one possible answer would be, what is a typical distance from home to school? So there is my distance from school. I get my variability by saying that I'm going to ask the students at my school. So here I have the data that I'm collecting, and here I have who I am collecting it from. Here is the information, and it is the who I am collecting it from, or what I am collecting it from, that will give me the opportunity for variability. I'm asking several hundred or maybe thousand students how far they live from school. So there could be a lot of variety in those distances. Okay, here we've got a question that we want to change and make it a statistical question. How old is my math teacher? Well, we're collecting data and age, but we're only collecting from one source. We're only collecting from one person, which means we won't have any variability. So we need to rewrite this question so that we can have variability. We could ask the question, what is a typical age for teachers at my school? Now we've got a whole bunch of different teachers we're collecting data from. We have the opportunity for variability. All right, there are two basic types of data that we collect. When we're collecting information, we've got two basic types. We have numerical data, which is numbers, and we have categorical data, which is more of words, labels that we would give. So if we record the age of 25 baseball cards, we're going to collect numbers. That's numerical data. Ages are recorded in numbers. Each value in a numerical data set is a number. Now, if we record the teams, what are the teams of the players? We've got the Red Sox, we've got the White Sox, we've got the Braves, we've got the Dodgers, we've got the Giants. Those aren't numbers. Those are categories. That would be categorical data when we have names that we assign to it. When we collect favorite colors, that's categorical data. That's blue, and that's red, and that's green. So although we would still have 25 data values, even though we'd have 25 different answers, the data is not numbers. It is these categories, these labels that we put on it. And they would be the team names. Each of those would be a category. We'd have a pile for the Red Sox, and we'd have a pile for the Blue Jays, and we'd have a pile for the Cubs, and we'd have a pile for the Astros, and we'd have a pile for the Mariners. So we'd put them into categories. So what are some other examples of categorical data? Pause and think about that for a minute. What are some other categories of data that you can think of? Well, we've got eye color, the month in which you're born, your favorite subject, your favorite book, your favorite movie, your hobbies. Those would all be types of categorical data. We would not be recording numbers for those. We would be recording these categories. So some other examples of numerical data. In the example up above here, we talked about ages. Well, We've got height, number of pets, how many minutes it takes to get to school, how many students in a classroom, how many marbles in a jar. Those are all numerical pieces of information. All right, so here we've got just a nice simple example here. We're going to identify, is this categorical or is it numerical? Well, if we've got the height of 26 graders, we're probably going to be measuring height in inches or centimeters or feet in inches. So that's going to be numerical. The favorite flavor of ice cream for each of 10 sixth graders. Well, one of them says chocolate and one says vanilla and a couple say Moose Tracks and some of them say Rocky Road. Those aren't numbers. Those are categories. Hours of sleep on a school night for each of 36 graders. I asked somebody how long they slept. They said, I slept this many hours. And somebody else says, I slept this many hours. And someone else says, I slept this many hours. These are numbers that we are collecting. Numerical data. Type of beverage drunk at lunch for each of 15 sixth graders. So we walk along the cafeteria table and we record what they're drinking at lunchtime. Well, we've got chocolate milk, we've got the white milk, we've got the juice, we've got water. These are categories that we are collecting. The eye color for each of 36 graders. So we walk around the classroom and we write down the eye color of each student. We've got blue eyes and we've got brown eyes and we've got green eyes. These are all categories. Number of pencils in the desk of each of 15 sixth graders. We walk around and we ask each student, how many pencils do you have in your desk? Well, each one of them is going to give us a number of pencils. That is numerical data. All right, so we're back to Jerome again. For each of the following statistical questions, identify whether the data Jerome would collect to answer the question would be numerical or categorical. Explain your answer and list 4 possible data values. So if Jerome asks the question, how old are the cards in the collection, is that a categorical question or is that a numerical question? Well, we measure age usually with numbers. So this would be numerical data. And if we were looking for some possible data values, we could have 2 years old, 2.5 years old, 4 years, 20 years, 50 years, 75 years, just a couple of months. If Jerome poses the question, where did he get the cards in the collection? Is that numerical or is that categorical? Well, let me think about that for a second. I bought these at Walmart and I bought these at the card shop and I got these at the flea market and I got some of these at a yard sale. Well, these don't sound like numbers I'm collecting. These sound like places or categories. This is categorical data. And you just heard me run through a list of places I could have got it, and these are some of the categories that you could have used. So in closing, what is a statistical question? A statistical question has 2 parts. Number 1, I can answer it by collecting data. Number 2, I expect there to be variety within the data, meaning all of the data values are not going to be the same. I'm going to have a variety of answers. What is the difference between a numerical data set and a categorical data set? Numerical data sets are numbers. Categorical data sets are more like labels that we would put on. Every value in a numerical data set is a number. The values in a categorical data set are not numerical. They're not numbers. They are categories, labels that describe what is in the group. All right, so here we are back where we started out. Statistics is about using data to answer questions. And in this module, we're going to work on 4 different steps. Today, we worked on identifying statistical questions, writing statistical questions, analyzing whether or not questions are statistical. Remember, a statistical question is one that can be answered by collecting data and where we expect there will be variability in the data. The data we collect is either numerical, numbers, or it is categorical. So that concludes Module 6, Lesson 1. I hope you have a good grasp now of what a statistical question is. Hopefully you took the time to pause and think your way through each of the exercises so that you can feel comfortable as you work on your assignments.